Okay, so one of the major things missing from our whole kind of getting damaged by enemies and stuff like that at the moment is when we hit against an enemy, we lose a bit of heart, but we don't go anywhere. It kind of looks like nothing really is happening. We just end up walking into him like this, and that's not really very good. We're just bouncing against this guy. That's no good to us. So we need a system that will actually make it look like we're bumping against him. Now we could add another particle effect that would create something in the world, much like we did before for when we're hitting off enemies and stuff like that, or when we're killing enemies, or when our player is being killed. So we could do another particle effect like that, which would be fine. That would show the damage, or it would show something happening basically when we run against an enemy. But what's the kind of more common thing to do within platformer games or 2D kind of sideways games like this in general is to have the player get knocked back into the air a tiny little bit, and then you go on with what you're doing. So that's what we're going to do. We're going to add the ability for the player to get knocked up into the air a tiny little bit and then continue on. And it'll look like we're actually taking a little bit of damage. So obviously, if we're going to do this, we're going to need to do it within the player controller script, because that's controlling everything about how our player moves in the world. So let's go ahead and open that up here. Do I have it open already? I do. Oh, here we go. Okay. So to control our knockback, we're going to need to have a few extra variables basically in here. So we'll obviously need to know how much force should be used to knock the player back, because again, we're going to need to take advantage of our rigid bodies for the forces within the world. So we want to move the player back by a certain amount. We want to know how long the player should get knocked back into the world for. So we would want our knockback to maybe last a half a second or a quarter of a second or something like that. So we want to know that value, and then we also need to have an extra value to keep track of that within the game. So we're going to do, for the first, we need to know the force. So we're going to do a public float. We call it knockback force. We're going to need how long it's going to last for, so that'll be our public float knockback length. And then finally we're going to need a private float knockback counter, we'll call it. So a counter will be used to count down the amount of time it takes for us to be knocking back in the game. So the reason we don't want to use knockback length is because we want to be able to set our knockback counter as soon as we hit against an enemy. We want to set that to be whatever our knockback length of time should be, and we'll set it to that. Say we set it to half a second, and it'll count down to 0, and once it gets to 0, it'll stop knocking us back in the world. So that should be everything we're going to need to implement our knockback system. I just actually noticed that our knockback force is spelled wrong here, so that'll be knockback force instead of conkback. Okay, so we're going to go down here below our kind of input stuff that we have going on here. So we're obviously going to need a new function to know when our knockback should be activated. So we're going to go down here, and we're going to create a new public void, and we're going to call this knockback. So basically this is going to be called whenever our player gets hurt. So we're going to add this into our hurt player script as well, and we'll be able to call this whenever we want. As soon as we hurt the player, or the player takes any damage or whatever, we're going to call the knockback, and it'll make our player knock back within the world. So obviously we're going to need to, within this little function, we're going to need to set our knockback counter that we're keeping track of. We want to set that to be whatever the length of time it is. So our knockback counter will be equal to our knockback length, like that. And that's pretty much all we're going to do in here. So what we want to do back up here now, so we have our input being taken here. So we have our horizontal movement, all that stuff, and our jumping up in the air. But if we're getting knocked back by our enemy, we don't want to be able to control anything in the game, because what we're doing there is we're taking control away from the player for that half a second or whatever it is. So basically we want to say, we're going to push just above this, we're going to say if our knockback counter is below 0. So basically what we're saying here is if we haven't got any knockback happening, actually we should say if it's below or equal to 0. So if there's no knockback counter if the knockback counter isn't above 0, then we know that we're able to actually do some movement. Because if it is above 0, that means that our knockback counter has been set and it should be ticking down time so that all of this stuff isn't happening. So what we have this if statement now, and we need to make sure that it wraps around all of these inputs. So what we'll do is just put a curly bracket like that before our first if statement, and then after our jump if statement, we put another curly bracket like this there. And now, the way this stuff is usually laid out, all this stuff in here should now be kind of indented in, so it's clear that these two different curly brackets are not working on the same kind of line. They shouldn't be on the same line, basically. So what we can do to fix that is if we highlight all of this here like this and go up to edit and then format and then indent selection, just like that. So now it makes sense that this stuff is all within this if statement here. So we've got this set now. So what happens if our knockback counter is above 0? So we're going to say here, if knockback counter is greater than 0, that means, first of all, we want our knockback to be counting down through time. So our knockback counter, not knockback force, sorry, knockback counter should be, we should say minus equals time dot delta time. So much like we've used time dot delta time before, it's ticking down by the amount of time it takes for one frame to pass into the next one. So it'll be ticking down really, really fast, but it'll be ticking it down in normal passage of time, basically. So if we had 1 second, it would be counting down at fractions of a second until it gets to 0. So if our knockback counter is counting down, that's absolutely fine. So we also know if that's happening, then we want to be doing the thing of making our player get knocked back into the air. So how are we going to determine, or how are we going to make our player get knocked back? Well, we're going to use our knockback force that we created back up here. So this is going to determine kind of how much energy gets pushed or pushes the player back. So we're going to say here, my rigid body dot velocity is equal to new vector tree, just like we've done this before. But now what we're going to say is, okay, if our player, we're going to assume that our player is facing to the right here. So if our player is facing to the right, we want them to get knocked back to the left. So we'll say, okay, so we'll use the minus knockback force. So it gets moved. Say we set our knockback force to be 5 or something like that. Then we'll get knocked backwards 5. And we also want to get knocked up into the air 5 as well. So we'll say knockback minus knockback force and knockback force. So we're getting knocked backwards and upwards at the same time. So we'll get knocked diagonally, but that will actually look good within the game itself. And again, as usual, we want 0 force on the z-axis. Okay, so that's perfectly fine. So if we were to save this now and go back into the game, let that compile down here, and we'll go over to our player, and we'll have an extra couple of slots to fill in here. So on our player controller script, so our knockback force, we'll set that to be 5. And our knockback length, we'll set that to be, we'll go for a half a second. So we'll hit play here, and we should see, if we walk over to our little spider guy here. Oh, well, yes, nothing's going to happen unless we actually add something to our hard player script to activate that. Actually, just thinking about it here, what would make much more sense is if we go to our level manager. So rather than adding some more code to find the player here, if we go to our level manager, which already knows what the player is, and we're already doing something when our player gets hurt, which is taking away a little bit of health and stuff like that. So we've got our hurt player here. So at the same time here, what we could just add in is the player, which is our reference to the player in the game, the player dot knock back. So that's the name of the little function we made, and we can put a semicolon at the end there. Just this one little code, or line of code, is all we need, and we can go back in here, let this play again, and we should see this time that we get knocked back up into the air just the way we want it to. So we walk over to the side here, walking this guy, and bam, we get knocked up into the air. Okay, that knock was that lasted a little bit too long. That's a bit crazy for us to be knocked that high in the air. So let's just try reducing it down to 1/4 of a second. And there we go. That looked a bit more reasonable. So it knocked us back just enough to be able to bounce on the enemy's head. So let's go back over here, test it out again on this little spike just to see how it looks. So yeah, it's just enough to actually to take control away from the player for just long enough that we're kind of satisfied with it. So the only problem with how we've added our knockback to our game right now is that if we were to walk, oh no, I fell down, but if we were to walk from the right towards our enemy, it actually ends up knocking us forward in the air. So that's obviously not what we want to happen. So we want to make sure that no matter which direction we're facing, we're getting forced backwards. So if we're facing right, we should be forced to the left, and if we're facing left, we should be forced to the right. And this is very, very simple to add in. So all we got to do is go back to our player controller and go back to where our knockback force is being applied here. So I'm just going to move this down a little bit. And basically what we want to do is say, okay, if we're facing right, we'll do this one. And if we're facing left, we'll apply it the other way around. So all we have to say here, because we know that our player, which direction our player is facing, is being decided by his local scale. So when his local scale is -1, then he's flipped around so he's facing the left. And when it's 1, we know he's facing the right. So what we can do here is just say if our transform dot local scale dot x, if it's greater than 0, then we know we're facing to the right. So we can run this whole little bit here. So let's just tab that so it's lined up like that. And then we can say else, because he's either got his local scale is greater than 0, or else his local scale has to be less than 0. Or it could possibly be 0 as well, but that's not really going to be something that we have happen. So if his rigid body or his local scale is less than 0, we want to do the opposite of this. So we want to just copy this whole line like that, and instead of doing minus knockback force, we'll just do a positive version of it. So now if we save all of this, go back in here and hit the play button one more time once it compiles in the corner, we should be able to see that if we now walk back to that spin saw guy here, bam, we get knocked back to the side just the way we want to be whenever we touch against the object. So perfect, that's exactly what we want to happen, and we get killed without getting knocked anywhere.